Hello, students, and welcome to our final lesson for this year in the distance learning that we are doing. This is section 7.5 on properties of logarithms. We are continuing the discussion of logarithms that we started in 7.4. And before we get into this, let me just say that this couple of sections here, or the whole unit actually on exponentials and log functions, is going to be very important for those of you who are moving on to pre-calculus next year. We use exponentials and logarithmic functions a lot next year. So it's important to have a good foundation because you're going to be seeing them again in the future. And even if you don't take pre-calculus next year, if you take any math classes down the road, either in high school or college, you'll see exponential and log functions. All right, so anyways, we introduced you to logarithms in 7.4. Now we're going to go through some properties of logarithms. So how to simplify and rewrite logarithms. They're going to be useful down the road when we get to solving equations with exponential functions and logarithms. So there's 7 properties of logs we want. The first 4 are kind of simple, and then there's these 3 rules that we're going to mostly focus on is the product, quotient, and power rule. But let's start with these 4 at the beginning. First property, log base b of 1. You probably already remember this from 7.4. No matter the base, log of 1 is always 0. No matter what the base is, the log of 1 is always 0 because b to the 0 power is 1 for any base. The next one, no matter what the base is, log base b of b is 1 because b to the first power is b, right? So those are pretty straightforward there. 3 is just kind of a continuation of 2. What is the log base b of b to the x? Well, why is this 1? Well, if you can think about it, b is really b to the first. Well, if I have any x, log base b of b to the x is just going to be x. And again, if you look back into some of the problems from 7.4, we did problems like that, where you had to solve a logarithm, but the number inside the log was written in exponential form. So what ends up happening, another way to think about this is go back to what we talked about with the inverse functions in 7.1. Remember that the log function is the inverse of the exponential function with the same base. So we can think of the log base b and the exponential base b as canceling out. You can think of this log and this b cancels out, and the answer is the exponent, the input and the output. Kind of like the square root of 5 squared is just 5 because the square root and the square root cancel out. Same idea. And 4 is also inverse property, just flipped around. This time the log function is inside the exponential function, but the same thing happens. The exponential and the log cancel out, so the answer is just x. So once again, the input here matches the output. All right, so 3 and 4, these two together, I want you to think of those as the inverse properties of logarithms. That anytime you compose a log function with an exponential function of the same base, because they're inverses, the log and the exponential cancels out, and the input equals the output. The input equals the output. All right. Now, onto the 3 properties of logs we're going to be using for most of this section. Product rule because there's a product inside, quotient rule because there's division inside, and power rule because there's a power inside a log. All right. This is a way to take a single log and break it up into multiple logs. And these come from the rules for exponents that you already know. Okay, when we're done here, I can kind of show you what I mean by that. So to start with, if you have a product inside a log, you can write it as a sum of 2 separate logs. So here's what I mean. Log base b of m times n is the log base b of m plus the log base b of n. So anytime there's a product inside a log, you add 2 separate logs with the same base. The base stays the same. Likewise, division, if you have division inside a log, it becomes subtraction of the 2 separate logs. And you probably guessed that after the first one. If addition becomes multiplication, division becomes subtraction. So it's log base b of m minus log base b of n. And then last one, power rule, log base b of m to the p. If you have a power inside a log, you can bring it down front as multiplication. So p times the log base b of m. So again, a power inside comes down in front as multiplication. Okay, so if you think about the exponent rules, let me just talk about that real quick. This should make sense, right? Think about what's x to the second times x to the third. What do you do when you multiply bases? You add the exponents. It's x to the fifth, right? Where does that 5 come from? 2 plus 3. So when you multiply bases, you add the exponents. Remember, the answer to a log is an exponent. So when you multiply inside the log, you add the separate logs. All right. Likewise, what's x to the fifth divided by x to the second? When we divide exponents, we subtract, right? 5 minus 2 is 3. So division is subtraction of the exponents. Likewise, division inside log becomes subtraction. And one last one. What happens when you have a power raised to a power? You multiply, right? X to the second to the third power, 2 times 3 is 6, right? Uh, you don't have to write these down. I'm just showing you where these rules come from. Anyways, multiplication becomes a power to power becomes multiplication. Likewise, a power inside a log becomes multiplication out in front of the log. Okay, so these these examples are just showing you where these rules come from. All right, but these are the properties we're going to be using here today with this with these examples. All right, so example one, simplify the expression. These are going to use the inverse properties. All right, example one is just using the inverse properties. If you notice, the log and the exponential here have the same base, same base, same base. Okay, this is common log, log base 10. This is the exponential base 10. So this log and the 10 cancel out, and the answer is just the exponent, m minus 7. Same thing here. This is the log base 8. This is exponential base 8. They both have an 8, so they cancel out. So the answer is just the exponent. Or I'm sorry, what's inside the log, 2x plus 1 in the exponent. The answer is 2x plus 1. The input becomes the output. Finally, e to the ln of 6y. ln means log base e. That's exponential base e. The e and the ln cancel out, and the answer is just 6y. All right, so once you know what to do there, those are pretty simple. Just recognizing you can only do that if the log and the exponential have the same base. All right, now we're going to get into these three properties. Write each expression as a sum or difference of logarithms. So um, these properties, we can actually go both directions with it. Sometimes we want to take a single log and break it up into multiple logs. Sometimes we'll go the other way, take multiple logs and write them as a single logarithm, okay? So sometimes we go left to right, sometimes we go right to left. In this example too, we're going to go left to right. We're going to take a single logarithm and break it up as multiple logs with a sum or difference between them, in other words, adding or subtracting. All right. So we're always going to apply these two properties first, and then we'll apply the power rule if necessary. So here's what I mean. 2a, log base 9 of the quantity x to the third times y to the seventh. So there's multiplication, there's a product going inside. So this says we break it up by addition. So it's going to be log base 9 of the first quantity x to the third, the first factor, plus log base 9 of the second factor, y to the seventh. So log base 9 of x to the third plus log base 9 of y to the seventh using our product rule. Now, notice we can use our power rule. Each of these logs has an exponent inside. Our power rule says that the 3 and the 7 come down in front of the log as multiplication. So then I can write this as 3 times log base 9 of x plus 7 times log base 9 of y, and I'm done. So that's what you want to do. Break up any product or division as adding or subtracting, and then bring down any exponents to the front. Let's do another one here. ln of 100a divided by b to the eighth. Okay, so we have division, so we're going to break that up as subtraction. But be careful. Be careful. Look in the numerator. 100 times a, that's also multiplication, right? So multiplication becomes addition. So I'm going to actually do 3 different logs. These 2 logs are going to be added because there's a product inside, and then the division becomes a subtraction. So here we go. Natural log of 100 plus, because it's multiplied, the natural log of a, and then the subtraction comes from the division. So minus natural log of b to the 8th power. All right, and then apply the power rule. Any exponents inside? Yeah, the b to the 8th. And the other two just stay the same. So natural log of 100 plus natural log of a minus 8 times the natural log of b. Okay, another one. Log base 3. What's inside here? I have 7n squared square root of m minus 1. So ask yourself, there's a product. How many different things are being multiplied? There's 3, right? There's the 7, there's the n squared, and there's the square root of m minus 1. So I need to break it up as 3 logarithms. Log base 3 of 7 plus log base 3 of n to the second uh, plus log base 3. And I'm going to rewrite, anytime you have a radical, rewrite it as a fraction exponent, like we talked about a couple units ago, right? Square root of m minus 1 is the same as m minus 1 to the 1/2 power. So I'm going to do that, m minus 1 to the 1/2 power. Now, um, now that I've done that, now I can apply my power rule. And the exponents I'm going to bring down in front. So log base 3 of 7 plus bring down the 2 times the log base 3 of n plus bring down the exponent 1/2 times the log base 3 of quantity m minus 1. Okay, now before I move on, a little word of warning. There is no distributive property for logs, so be careful. Sometimes when students see the subtraction, they want to do log of m minus the log of 1. But notice, you cannot do that. Look at my rules here. There's no rules for breaking up adding or subtracting inside a log. Adding or subtracting two different logs can combine into a single log, but there's no rule for breaking up adding or subtracting inside a log. So when you have subtraction like this inside a log, stop. There's nothing else you can do about it. Okay, last one here. Example 2. We have inside the ln fifth root of x to the 4 plus 6 over y to the 8th. And there's one factor in the numerator, one in the denominator, and there's a subtraction. So I'm going to break it up as 2 logs with a subtraction between them. So here we go. It's going to be the natural log of x to the 4th plus 6. And once again, I'm going to rewrite any radical as a fraction exponent, so to the 1/5 power. All right. Then minus the natural log of y to the 8th. All right. And then the power rule, I'm going to bring down the 1/5 and bring down the 8. So this will be 1/5 times the natural log of x to the 4th plus 6 minus 8 times the natural log of y. Okay. Now, once again, pause here for a moment. There's an adding inside here. The log, we cannot break it up. Now be careful. You see that 4 there. You might think, well, can't I bring that 4 down like I did the 1/5 because it's a product, because it's a power, excuse me. But be careful. The whole x to the plus 6 is not to the 4th power. It's x to the 4th power plus 6. All right. So the only exponent you can bring down is a power that's on the whole thing, the 1/5. Okay. You cannot break up the x to the 4th plus 6. And then, so there you're done. That's done. There's your final answer. Okay. So I'm going to stop there and give you your first homework assignment from the 7.5 homework that I posted. So here we go. All these homework problems look like example 1 and example 2, simplifying and then writing is a sum or difference of logarithms. And I will post this on the website, but if you want to write down now from this 7.5 homework page, please do 2 through 10 even, 11, 13, 16, 19, 22, 24 through 27, and 29. Okay, so work on that assignment, share with me, and then I'll share a second video going over the examples on the back of 7.5.